Right, so section 5.6, we're going to take a look at trigonometry in the coordinate plane. So prior to this, we've been talking about our 6 trig ratios, our sine, cosine, tangent, cosecant, secant, and cotangent. And now we are going to evaluate those being on the coordinate plane. And how do you find 6 trig ratios when you are just given a particular point? So and also we're going to be splitting this section up into 2 days. So when you look at your homework for section 6, you'll be able to do the first 4 problems. And then the back side, we'll be able to do that after tomorrow once we talk about the unit circle. Alright, so I'm going to take you guys back to, back when we initially started this chapter and we talked about what an angle was. We talked about the term that was given to us in geometry, and now we're talking about it as like a rotating ray. And we're going to take this angle and now we're going to put it into the coordinate plane. Now, you have your initial side, which is going to start on your x-axis, pointing towards the 3 o'clock position. Your terminal side is going to be the ray that is rotated around the origin, okay, until it gives you that particular angle. And I'm going to refer to our angle right here then as theta. So what we're going to be doing now is trying to find some different values for a given point. So here we're going to get into quadrant trigonometry. Slide down here. And we have this point of 5, 3. And we're trying to figure out what are the 6 trig ratios that are associated with the point of 5, 3. So what's happening here is you're taking this point and you're taking this segment here and you are rotating it about the circle, okay? Now understand that that point is not over here at 5, 3 because it's the location, it's the coordinates of that. Well, what I want you to think about here is that we can set this up actually really nicely if you were to think of this being a triangle. And more importantly, having it be a right triangle. Because there's a lot of information that you actually know right now. Because from theta here and from that coordinate of 5, 3, we know that the base has to be 5 units. We know that the height has to be 3 units based off of the coordinate that's given to us. Now, if we know that information, we can also find our hypotenuse as well. 5 squared plus 3 squared is going to give us our hypotenuse squared. So 25 plus 9 is going to give us 34. And so 34 is equal to c squared. So that means our hypotenuse here is the square root of 34. And 34 cannot be simplified any further, so we'll just leave it like that. So now you have a triangle. And to find our ratios now, if here's my angle of theta, sine is opposite over hypotenuse. So 3 over the square root of 34, which we could simplify that to 3 square roots of 34 over 34 then for your sine. The cosecant is going to be the reciprocal of that, so square root of 34 over 3. Cosine is adjacent over hypotenuse, so 5 divided by the square root of 34. Rationalize it, we get 5 square roots of 34 over 34. Secant is the reciprocal of cosine, so square root of 34 over 5. And how about tangent? Tangent is opposite over adjacent, so that would be 3 over 5, and cotangent would then be 5 over 3. And so we have the 6 trig ratios that are associated with the point of 5, 3. Now what happens if I took that point and I moved it over into the second quadrant? Well, what's going to happen to our trig ratios at this point? Well, you can still set up a right triangle. And we can use the coordinates of -5 and 3 because my base would be -5, my height would be +3. And here's where it just gets to be a little tricky because your angle of theta is right here. It's on the outside. Well, to come up with our ratios here, you are going to treat theta, and I'm gonna go ahead, put theta here. You're gonna treat it like it's inside this triangle, and the angle is always going to be along your, connected to your x-axis, okay? And I'll get into that here as we start looking at what theta is actually meaning. Now, with that point of 5 and 3, if I find my hypotenuse, just like we did before, negative 5 squared plus 3 squared equals c squared. So that part is not going to change. And the fact that you have negative 5 squared, so that's 25, and the 25 plus 9, so that's going to give us the 34 equals c squared. So your hypotenuse is going to be its square root of positive 34. And your hypotenuse should always be positive because you're working with positive numbers. So with our sine value then, sine is opposite over hypotenuse, so I have 3 over the square root of negative 34. Rationalize it, we get 3 square roots of 34 over 34. Cosecant, we get the reciprocal of that, square root of 34 over 3. Now, those are no different than the ones that we saw in the past problem. Now when you get to cosine, though, the adjacent side is negative 5 divided by the square root of 34. So now you get negative 5 square roots of 34 over 34. Your cosine is negative versus on the previous problem where it was positive. Secant is going to be negative as well. Negative square roots of, or I should say, square root of 34 over negative 5, which ends up making that value negative. Tangent is also going to be negative because you're taking the opposite over the adjacent. 3 divided by negative 5 is a negative 3/5. Negative 5 divided by 3 is a negative 5/3. And so here you end up with cosine, secant, tangent, and cotangent all being negative. And the reason for that is they're all negative because of this negative 5. Because we're going over into the second quadrant here, it's making your x value negative. Your y value staying positive, your hypotenuse right here is going to stay positive. And so this brings me into the trigonometric functions of any angle. It says let theta be any angle in the standard position and let p, xy, be any point on the terminal side of the angle except the origin. Let r denote the distance from p of xy to the origin. Now, what's it's doing right here, and the reason why I'm using that r is really think of it as being the radius. You are rotating a point around the origin, which really means you are making a circle. So we are going to let r be your hypotenuse. And here I have r equals the square root of x squared plus y squared. That's your Pythagorean theorem right there. So to always find your hypotenuse, which in our case is going to be our r, you're going to set up your Pythagorean theorem. Now your ratio is based off of this. Because your sine is opposite over the hypotenuse, based off of your angle here, your y value, your y coordinate is always going to tell you the opposite side. And there's your hypotenuse. Cosine, well, your x coordinate, which is the base of your triangle, is always going to tell you what your adjacent side is. And then you got your hypotenuse. Tangent is y over x. Now think about what else is y over x. And slope is the same thing as y over x. When you're actually finding the tangent, you are finding the slope of that line because you're taking essentially the rise over the run. You're taking the change in y over the change in x. All right? And your reciprocal functions are going to follow suit with that. Now, along with this, once you're in quadrant trigonometry, you've got to be aware of then what's happening to your values of sine, cosine, tangent, along with their reciprocal functions as well. Now, when you are in the first quadrant, top left here, your x and y are both positive. And know that your radius is always going to be positive. Your hypotenuse is always positive. So, with that being said, if you're taking the sine, if you're taking your y-coordinate, which is positive, divided by the hypotenuse, which is positive, your sine value in quadrant 1 will always be positive. Cosine, you're taking your x value, which is positive, divided by the hypotenuse, which is positive, so you end up with a positive. Here, tangent, you're taking y over x. They're both positive, so your tangent is always going to be positive. Every single trig ratio will be positive when you are in quadrant 1. Now that's going to change when you're in quadrant 2. Because now when you're looking at sine, you're taking y over r. Well, y is positive. Positive divided by a positive is positive. Cosine, you're taking your base here. Your negative divided by a positive. So cosine is going to be negative. Tangent, when you look at that part, you're taking y over x. So a positive divided by a negative is a negative. All right, what happens when we get into quadrant 3? Sine. You're taking your y value, which is negative, divided by a positive radius. So overall, your sine value will be negative. Cosine, when you take x, which is negative, divided by a positive radius, you get negative. Tangent, y divided by x, negative divided by a negative is a positive. Over into quadrant 4, your sine, we're going to take y over r, which will make it negative. Cosine, positive divided by positive is a positive. And then tangent, negative divided by positive, makes it a negative. So now how are we going to remember this? Well, there's a little acronym here. All students take calculus. Now we know that's not necessarily true, but we can use that to help us here. So the first part here, all. That tells us that all, sine, cosine, tangent, secant, cosecant, cotangent, all of those trig ratios are always going to be positive. When you get to the next part here, you see students. Students starts with an S. That means that only sine is positive. Now along with it, the cosecant is going to be positive as well. But cosine and tangent are both negative. Get down to quadrant 3. We got take. Starts with a T. Only tangent will be positive in quadrant 3, along with cotangent. The others will all be negative. We get into quadrant 4, we have calculus. Starts with a C. That means that cosine and secant will be the only trig ratios that are positive. So remember that all students take calculus, and that should help you out. Now if I go back to here, right here. Okay, so now if I take and look at this problem, now the reason why I'm putting this angle down here is because I want to create a right triangle to help me create these trig ratios, okay? Working with this value of theta is really important because if I'm putting something over here into quadrant 2, that means that we need to be rotating this angle a certain amount. I'm just going to go ahead here and figure out what my angle would be in this situation. 1 second, sorry. Okay, so we're going to approximate this angle to be about 149.04 degrees. Okay, so we're going to approximate it to be that. The fact that it's 149.04 degrees, that puts us into quadrant 2. Now, that means that this angle in here, because this is a straight line, its supplementary angle, if I take 180 and subtract 149.04, this interior angle here ends up being 30.96 degrees. Okay, those two angles have to add up to 180 degrees. If I were to take, and I've took my calculator here, if I were to take the sine of 30.96 degrees, and I hit enter, now I'm going to get approximately the same thing that we get here. And I'll just show you that 3 divided by the square root of 34. Okay, so notice that those are practically the same. Now they have a little bit of round off error because I rounded that angle up there. But now, what happens if I take the cosine of 30.96 degrees? I get 0.85, and we know that our answer is going to be negative. Well, that's because your calculator is very smart. And your calculator says, okay, 30.96 degrees. Well, 30 degrees is between 0 and 90. Your calculator is putting this coordinate right here in quadrant 1. So it's treating it like positive 5, positive 3 if you're working with 30.96 degrees. Instead, you're really using 149.04. So when I take the cosine of 149.04, now notice I get practically that same answer right here, just the negative. And so this angle that I'm using to help me with the triangle is just for a visual representation where really you are using an angle that's greater than 90 degrees to put us into quadrant 2. So now let's take a look at another example here of where I give you a trig ratio, and you have to find the other 5 trig ratios along with that. So cosine of theta is equal to 4/7. Cotangent of theta is greater than 0. Now that's going to be important here in a minute. There are 2 quadrants where cosine is positive. Remember, all students take calculus. So where I look here and I see that cosine is positive, I know that cosine is positive in the first quadrant. It's also positive in the second or the fourth quadrant. So in trying to figure out this problem, I have to set up a triangle, and I need to know which quadrant to set it up in so that I have the corresponding ratios have the correct sign value associated with them. So then I look at this next piece of information that's given to us here, and it says that cotangent of theta is greater than 0. It's the same thing as tangent. That's telling us that tangent has to be positive. So which quadrants is tangent positive in? Well, tangent's positive in quadrant 1 as well as quadrant 3. So this tells us right here where these 2 check marks are that we can set up our right triangle here in quadrant 1. And here's where theta is going to be. Theta is always going to be associated with your x-axis here. So if the cosine of theta equals 4/7, that means that the adjacent side here is 4 and our hypotenuse is 7. So if I'm going to now set this up to find the sine of theta, and I'm going to set it up to find the we already know cosine, the tangent of theta, I am going to need to know that opposite side. So Pythagorean theorem, 4 squared plus x squared is equal to 7 squared. So 7 squared subtract 4 squared gives us 33. So x squared equals 33. That means that our opposite side here is the square root of 33. So to set up my sine ratio here, I'm going to take my theta. Opposite of that is the square root of 33. And the hypotenuse is 7. So there is the sine of theta. Tangent is opposite over adjacent. So square root of 33 over 4 is our tangent. Now along with this, we could most definitely find our cosecant and our secant and our cotangent of theta. Cosecant is just going to be that reciprocal, so we're going to have 7 over the square root of 33. So that will simplify to 7 square roots of 33 over 33. Secant is the reciprocal of cosine, so positive 7/4. And cotangent would be 4 over the square root of 33, which rationalizes to 4 square roots of 33 over 33. And now you have your 5 trig ratios for this problem. Okay, let's take a look at another one. here I have tangent of theta is equal to -3/2, and the cosecant of theta is greater than 0. So we're going to take a look at which quadrant are we in. So right here, it tells us that the tangent of theta is negative. So when you think of all students take calculus, we're going to look at which quadrant is tangent negative in. And that puts us in the second quadrant as well as the fourth quadrant. Then I take a look at, well, which quadrant is the cosecant of theta greater than 0? Now when you think about cosecant, remember that's the same thing as the sine. So the sine of theta needs to be greater than 0. So the sine is greater than 0, being it's positive in quadrant 1 as well as quadrant 2. So where I'm going to draw out my triangle here is in quadrant 2. I'm going to put theta right here, tangent being -3/2. So tangent is opposite over hypotenuse. Opposite here is going to have to be +3 because it's going above the x-axis. Your x value here, that's going to be your -2. So 3 over -2. Finding our hypotenuse here, 3 squared plus a -2 squared equals our c squared. So you've got 9 plus 4, which is 13. So square root of 13 is going to be your hypotenuse. So allowing us to find the sine of theta, which is the opposite over hypotenuse. So that would be 3 over the square root of 13. Rationalize that to 3 squared roots of 13 over 13 for sine. Cosine of theta would be the adjacent over hypotenuse, so -2 over the square root of 13. So -2 square roots of 13 over 13. And we already know tangent is going to be -3/2. To find its reciprocals, you've got your cosecant of theta, which would be a positive square roots of 13 over 3. Your secant of theta would be a negative square root of 13 over 2. And then your cotangent of theta would be a -2. Alright, so there you have being able to set up and find the different ratios given a certain part of your quadrant.